I'd like to do is review getting displacement from a velocity time graph and apply it to an accelerating object, or an object that's changing velocity, speeding up or slowing down. First off, let's clarify that displacement is the same as change in position. Which is abbreviated delta x, which answers the question of how far an object travels. These guys are all synonymous. In other words, they all mean the same thing. What we've seen before is we've taken a velocity time graph, and this is in meters per second, and this is time in seconds. And let's do this for something like, say, 1, 2, 3, 4, 5 seconds. And let's see, we've got 2, 4, 6, 8. So that'd be 2, 4, 6, 8 meters per second. And let's say we've got a graph that looks something like this. Horizontal line, which means that this is moving steady away at a constant velocity. Say their question is, how far does the object move in the first 3 seconds? Well, what I'm looking at is how far Well, that means I'm looking for a displacement. Matches up here with how far. So displacement is equal to the change in position underneath the graph. In the first 3 seconds. So this area under here is my change in position, or my displacement, or delta x. Well, looking at this, in order to get the area, I would take the base times the height. Here's my base of this rectangle. Here's my height of this rectangle. So that would be my change in position. Let me do this. Means that change in position is going to be equal to 3 seconds times 6 meters per second. I've got seconds on the top and seconds on the bottom, so my seconds cancel, and I'm left with meters, which makes sense because I'm looking for how far. How far would be a distance, which would be measured in meters. So this winds up being 18 meters. We can do this for an accelerating object just as easily. Let's say that we have a velocity time graph that looks something like this. And velocity in meters per second, time in seconds. And let's see, we've got 1, 2, 3, 4, 5, 6, 7. So we've got 6 seconds, and let's say we've got 2, 4, 6. Positive, 0, minus, negative. All right, so let's say this graph looks something like this. That would be speeding up away. And let's say my question is, what is the displacement of the object in the first 3 seconds? So again, the area underneath the graph, area is equal to the change in position. So I'm going to go to my 3 seconds here. 3 seconds. This is my change in position in here. So I'm looking at the area of a triangle this time. So that area of a triangle is going to be equal to 1/2 the base times the height. So again, I'm looking at a base of 3 seconds and a height of 2 meters per second. So that change in position is going to be equal to 1/2 times 3 seconds times 2 meters per second. Again, I've got seconds on the top and seconds on the bottom. They're going to cancel out. I'm left with meters. Change in position is always in meters. Change in position is always in meters. Now let me rewrite this. Change in position units is always a distance unit, like meters, centimeters, kilometers, etc. Anyway, I do the math here and I wind up with 3 meters. 1/2 times 3 times 2. It's going to be basically 1/2 times 6, which is 3 meters. Again, it's done the same way, just a different shape, just a different area.